first thing I'd do is grow the ruler to shrink the distance, then go the distance under that ruler, and then I'd shrink the ruler back.
One of the huge problems with space travel is the massive distances involved. This has confined humanity to a corner of the cosmos despite our natural instinct to always explore. However, we might have found a solution to this problem as Joe Rogan, the popular podcaster, reveals how scientists have managed to open a portal with the help of an intriguing space-time modification technology. Want all the details about this shocking technology? Stay tuned to the end of this video. Why do humans go into space? While there are multiple possible answers to this question, one universal fact is that going to deep space is no easy endeavor. It requires a huge advancement in technology to be able to cover the vast distance involved in space travel. For example, the nearest star to Earth is the Sun, which is about 93 million miles or 149 million kilometers away. The second nearest star to Earth is Proxima Centauri, which is part of the Alpha Centauri system. Proxima Centauri is about 4.24 light-years away from Earth, which means it would take about 4.24 years to reach it if we could travel at the speed of light. However, with current technology, we can't travel anywhere near the speed of light. The fastest spacecraft ever launched by humans was NASA's New Horizons probe, which reached a speed of about 36,000 miles per hour or 58,000 kilometers per hour when it flew past Pluto in 2015. At that speed, it would take about 78,000 years to reach Proxima Centauri. And what that means is that we can't travel to Proxima Centauri unless we find a way to travel faster. And when Joe Rogan invited guests onto his popular podcast, The Joe Rogan Experience, he asked them what technology could make this happen.
And what would be the technology that someone could use to access that?
And one of the answers to Rogan's question is space-time modification technology. For many people, space-time modification might be a strange topic and appear like jargon, but it is an active technology that scientists are working on and which holds a lot of promise for our future as an interplanetary species. But firstly, what exactly is space-time in a language that non-scientists can understand? Space-time is a mathematical model that integrates the 3 dimensions of space and the 1 dimension of time into a single 4-dimensional continuum known as space-time. Space-time represents the physical reality of the cosmos as well as how various events and phenomena are related to one another in terms of their positions and durations. Space-time was first proposed by the mathematician Hermann Minkowski in 1908 as a way to reformulate Albert Einstein's special theory of relativity, which showed that the speed of light is constant and that space and time are relative to the observer's state of motion. Space and time, according to Minkowski, are not different things but rather aspects of a single phenomenon called space-time, which can be distorted by the presence of mass or energy. He famously said, "Henceforth, space by itself and time by itself are doomed to fade away into mere shadows, and only a kind of union of the two will preserve an independent reality." A 4-dimensional coordinate system can be used to describe space-time, with each point named an event and having 3 spatial coordinates, x, y, z, and 1 temporal coordinate, t. And the space-time interval is the distance between 2 events in space-time that remains constant regardless of the reference frame. However, depending on their relative velocities and placements, various observers may disagree on how to measure the space-time gap. 2 occurrences that are simultaneous for one observer may not be simultaneous for another who is moving at a different speed. This is referred to as the relativity of simultaneity. And space-time is a dynamic and fluid framework that can be bent by the presence of mass or energy. And Einstein advanced this concept in his general theory of relativity, which expanded on his special theory of relativity to incorporate gravity. Gravity, according to general relativity, is not a force that operates between masses, but rather the result of the curvature of space-time induced by masses. Gravitational fields are created where masses bend space-time around them, affecting the motion of other masses and light. The greater an object's mass, the more space-time it curves and the stronger its gravitational field. And extreme phenomena such as black holes, which are regions of space-time where gravity is so strong that nothing can escape from them, gravitational waves, which are ripples in space-time caused by accelerating masses, and wormholes, which are hypothetical shortcuts in space-time that could connect distant regions of the universe or different universes, can also all be caused by space-time curvature. Now, the concept of space-time modification has captured the imagination of scientists, researchers, and science fiction enthusiasts alike. It encompasses the idea of manipulating the fabric of space and time, allowing for potential alterations in the fundamental structure of the universe. The ability to modify the four-dimensional continuum of space and time is referred to as space-time modification. It implies that it may be possible to change the geometry of space-time itself, bending or warping it in ways that were previously thought to be only feasible in science fiction. Such changes have the potential to revolutionize our understanding of the universe and open up new avenues for technology and exploration. The foundation of space-time modification lies in Einstein's theory of relativity, which established that space and time are not separate entities but are intricately intertwined to form a unified fabric known as space-time. The presence of huge objects, according to this theory, can strain the fabric of space-time, resulting in the phenomena we call gravity. Based on this knowledge, scientists have investigated the possibility of making deliberate changes to space-time. To explain the possibility of space-time alteration, several theoretical frameworks and ideas have been offered. Some of these ideas involve manipulating gravitational fields, such as creating negative energy density regions or utilizing exotic forms of matter with strange properties. These approaches try to change the curvature of space-time, allowing the development of wormholes or the manipulation of time itself. However, it is important to distinguish space-time modification from the concept of time travel. While both entail manipulating space-time, time travel often refers to the ability to traverse the time dimension, allowing movement between different points in time. Space-time modification, on the other hand, focuses on changing the structure and features of space-time rather than enabling temporal displacement specifically. Now, despite its allure, space-time alteration remains a highly speculative field. The scientific community is still investigating the theoretical underpinnings and experimental possibilities of this topic. However, researchers have created mathematical models and simulations to investigate the ramifications of space-time modification on physical laws, causality, and the nature of the cosmos. Current space-time modification research is multidisciplinary, drawing on ideas from general relativity, quantum mechanics, and other fields of theoretical physics. Scientists are looking at the possibility of manipulating space-time using advanced technologies and materials, stretching the boundaries of our understanding and technical capabilities. While the field is still in its infancy, there is enormous promise for future improvements in space-time alteration. Faster-than-light travel and the production of stable wormholes for efficient space exploration could be practical uses. However, enormous obstacles and restrictions remain, such as the need for massive amounts of energy and the maintenance of causality in the universe's integrity. Nevertheless, one area of interest is the study of wormholes, which are hypothetical shortcuts in space-time that connect distant regions or even universes. While wormholes are only a theory, scientists are investigating the feasibility of creating and stabilizing them. Theoretical investigations and mathematical modeling show that the existence of exotic matter with negative energy density may be required for traversable wormholes. However, the practical difficulties connected with stabilizing and transiting wormholes continues to have substantial impediments. And aside from wormholes, scientists are investigating the possibility of manipulating space-time in order to accomplish faster-than-light travel. The notion of warp drives, popularized by science fiction, is enclosing a spacecraft in a bubble of modified space-time, allowing it to travel faster than the speed of light. While the concept of warp engines remains extremely speculative, scientists are always looking for new ways to overcome the restrictions imposed by the speed of light. Cesar Pais is an aeronautical engineer and inventor from the United States who works with the United States Space Force. He He has filed many patents for the US Navy using space-time modification technology, which is a hypothetical notion that suggests manipulating the fabric of space-time to accomplish faster-than-light travel, gravity-defying propulsion, and extreme energy creation. His patents are based on his own hypothesis of the Pice effect, which states that high-energy electromagnetic fields can be produced by manipulating the accelerated spin or vibration of electrically charged materials. One of his inventions is a plasma compression fusion device which he claims can emit extraordinarily high energy levels, making the hydrogen bomb appear more like a firecracker. He refers to this gadget as a space-time modification weapon that might be used for power generation, propulsion, and defense. According to documents obtained by the War Zone, the US Navy tested this gadget under the project name the High Energy Electromagnetic Field Generator, HEMFG, from 2017 to 2019. The documents include precise technical drawings, pictures, and statistics pertaining to the HEMFG testing. Pice also has a patent for a craft using an inertial mass reduction device, which he claims can generate a bubble of twisted space-time around a spaceship, allowing it to move without really moving. The work is done by space itself. This notion is based on the Star Trek series warp drive concept. Pice further says that this vessel can function both in the air and underwater as a hybrid aerospace underwater craft, capable of engineering reality at its most fundamental level. Pice has also patented a piezoelectricity-induced room temperature superconductor that he claims can transmit electrical power with no losses. He also claims to have developed an electromagnetic field generator technology that can change the trajectory of Earth-bound asteroids over time. These devices, however, are still awaiting validation by independent sources. Now, one area of research you might not have heard of is space-time coding digital metasurfaces. These are metasurfaces that may modify electromagnetic waves in both the spectral and spatial domains utilizing spatio-temporal modulation. They're based on the concept of space-time coding, which is a mechanism for encoding information in both the space and time dimensions. Space-time coding digital metasurfaces enable complex wave manipulations such as harmonic beam steering, beam shaping, and scattering signature management. They can also be employed in information systems such as wireless communications, cognitive radars, adaptive beamforming, and holographic imaging. Space-time coding arrays of sub-wavelength metallic patches printed on a grounded dielectric substrate form digital metasurfaces. Each patch functions as a meta-atom that can be controlled digitally by an external bias voltage to transition between two states, on reflective and off absorptive. The metasurface may generate variable phase and amplitude distributions on its surface by applying different coding sequences to distinct patches, which can then be utilized to alter the reflected wavefronts. Furthermore, by varying the coding sequences over time, the metasurface can alter the frequency spectrum of the reflected waves, resulting in harmonics that can be used to guide or focus the waves in different directions. Several research groups have demonstrated space-time coding digital metasurfaces experimentally at microwave frequencies. Examples of proof-of-concept applications include harmonic beam steering. By applying a periodic space-time coding sequence to a digital metasurface, numerous harmonics of the incident wave frequency can be generated and steered in different directions based on their ordering. This can be used to build a multi-beam antenna system capable of communicating with several users or satellites at the same time. Harmonic beam shaping. By applying a non-periodic space-time coding sequence to a digital metasurface, a single harmonic of the incident wave frequency can be generated and shaped into the desired radiation pattern. This can be utilized to build a beamforming system that can modify its radiation pattern to improve signal quality or coverage. Scattering signature control. It is feasible to diminish or eliminate the radar cross-section RCS of an object covered by a digital metasurface by applying a random space-time coding sequence to the metasurface. This can be utilized to create a stealth system capable of evading detection or identification by radar systems. Space-time coding digital metasurfaces are an exciting new technology that opens up new opportunities and difficulties for electromagnetic wave manipulation and information processing. They could find useful applications in a variety of domains, including wireless communications, cognitive radars, adaptive beamforming, holographic imaging, and others. However, before PICE, one brilliant scientist had worked on warping space-time. Miguel Alcubierre is a Mexican theoretical physicist at Mexico's National Autonomous University, or UNAM. He is known for suggesting a concept of faster-than-light travel that does not violate general relativity principles. His concept, known as the Alcubierre drive or Alcubierre metric, was published in the journal Classical and Quantum Gravity in 1994. The Alcubierre drive is based on the concept of enclosing a spaceship in a bubble of deformed space-time, allowing it to move without really moving. Space itself does the work. The space behind the bubble would expand while the region in front of it contracted, resulting in a wave that would propel the bubble and the spaceship inside it at an arbitrarily high speed. The spaceship would remain in a zone of flat space-time within the bubble with no acceleration or tidal effects. The Alcubierre drive was inspired by the Star Trek series warp drive concept. The Alcubierre drive has a number of benefits and drawbacks. On the plus side, no exotic propulsion system or fuel is required, and no time dilation or causality violation occurs. It also avoids the issue of traversable wormholes, which are another possibility for faster-than-light travel but require negative energy or exotic matter to remain open and stable. On the negative side, the Alcubierre drive necessitates the use of negative energy or exotic matter to produce and maintain the bubble of warped space-time, and it's unclear if such stuff exists or can be manipulated. Furthermore, when the bubble decelerates or stops, the Alcubierre drive may emit tremendous amounts of radiation, and it may not be controllable or steerable from within the bubble. The Alcubierre drive has sparked a great deal of interest and debate among physicists and science fiction lovers alike. Many studies have followed up on his model and attempted to address its challenges and limitations, such as finding alternative Einstein's field equation solutions that may be more feasible or realistic, investigating the quantum effects and stability issues of the warp bubble, investigating the possibility of detecting or communicating with a warp bubble, and estimating the energy requirements and efficiency of the warp drive. Some researchers have also developed warp drive equivalents or experimental experiments using optical or acoustic mediums.